Well, hello everyone. Welcome. Hey. This is the first PagerDuty Elastic Lisbon user group. We hope that is the first of many others. And thank you for coming today. Thank you for the help of the guys from Elastic for organizing this with us. And we'll have three amazing speakers today, Tiago and Bruno from PagerDuty and Lionel from Elastic. Then after, we'll have some food and drinks in the kitchen area. I just wanted to let you know that just a couple of housekeeping items. So the bathrooms are right next to the kitchen. The fire exit is the same as the entrance. And anything that you need, just look up for me in the middle of the event. And we should be starting with Tiago Barbosa, who's going to present himself.
Thank you, Shanda. Welcome, everyone. So Bruno and I are going to do a session here. Bruno, if you want to introduce yourself as well, then you can see it again. So basically, we'll do a session here on optimizing operations with the PagerDuty Elastic Integration. So I'll show you how to set that up. And just very quickly, my name is Tiago Barbosa. I am a senior developer advocate at PagerDuty. You have my contacts over there. I can share them later. Yeah,
thank you, Tiago. My name is Bruno Dias. I'm a technical account manager from PagerDuty. I work in the professional services team, and I work with customers and organizations to automate and streamline processes using our solutions from PagerDuty. So my contacts are also here. So any question, just reach out.
Thank you. And so basically today we bring basically I'll spend most of the time on the demo, which is, I believe, the most fun part of it. But I want to start with explaining what PagerDuty is, and just as a show of hands, anyone using PagerDuty? Perfect. Okay. Okay, that's great. And so I'll just cover briefly what is PagerDuty, what we can do with PagerDuty, some of its capabilities, because most people use PagerDuty from an incident management perspective and kind of don't use all the other features that we provide. So I'll try to give you like a quick overview on that. And then I'll focus on the integration with Elastic, and we will do hopefully a fun demo with everything working. And that's going to be part of the large part of this. And in the end, we'll have Q&A, but feel free to kind of ask any questions during the presentation. And so starting with PagerDuty, so most people, as I said, know PagerDuty from the incident management perspective. It's PagerDuty is well known for calling you in the middle of the night, waking you up, but it would be a lot worse if we didn't call you. Most probably, right? But yeah, so we do a lot more, and basically we are presenting PagerDuty under this umbrella of PagerDuty Operations Cloud, where we have not only the incident management side of things, where we kind of try to get the right people involved in the process at the right time, but we also have like things like AI Ops, which basically allows you to kind of group incidents together in an intelligent way. Just make sure that instead of getting like every single alert triggering an incident, we kind of group them together by recognizing patterns, and we potentially create one incident from like hundreds of events that you are getting on PagerDuty. We will also let you know about things like if you have, for instance, a GitHub integration, we will also let you know, okay, you made a change in your code recently, and for that reason, this might be correlated to the incident you are having, because the error message that we are getting actually matches, or the stack trace actually matches this same function that you updated in your code. So we'll do part of the job for you. We also have like PagerDuty process automation, which basically allows you to automate some of the tasks that you typically do when on an incident management point of view, but not only. And this is something that Bruno will focus on the demo later on. So I will not spend a lot of time there. We also have integrations with tools like ServiceNow and other tools from a customer service operations point of view. So for larger organizations where you have like an help desk team, a support team that typically has uses these tools on a daily basis, we have integrations with those as well. And we have recently launched, still not in GA, but we have the PagerDuty Copilot. If you are interested in knowing more, we have a bunch of the folks from the Copilot team. They are here today. So if you want to ask them questions, yeah, they are here. They can help. So what's the idea behind PagerDuty, first of all? So as I said, from an incident management point of view, it's basically one of our strengths, but we do a lot more. And basically the idea is to move from this scenario that we all know. We have probably worked in many different organizations, and we have seen all of this happen, right? We have a lot of different tools that typically require some glue, right, to make sure that everything is connected. And under times of pressure, when an incident is going on in our platforms, it's very challenging to go in all these different tools and try to understand what's actually causing the issue that we are facing. So we are talking about scenarios and situations where we are kind of losing money, where we just don't know what's happening because we have tools that are giving us some events and we have other tools giving us events that are kind of pulling us or pushing us in a different direction. So it's very difficult to kind of make some sense of all these data that we are generating. And so the idea behind PagerDuty is essentially to send all events into PagerDuty. So you have like your DevOps tool sending events into PagerDuty. These will be change events. Every time you make a change in your code, you will get that information into. So all the commits will be sent into PagerDuty, and they will be analyzed there. We have integrations with your observability tools, Elastic, one of them, of course, and yeah, with your cloud providers. So you'll be able to collect all that information and send it to PagerDuty, and of course integrate with all your collaboration tools, whether you use Slack or Microsoft Teams or whatever. We have integrations for those, so you don't need to. And that's one of the powers of PagerDuty, is that you don't need to learn yet another tool, right? So you can still work on the tools that you work today. We will just make sure that we will enrich the information. We will reach out to you as well through the channels that you already use. And from an Elastic perspective, it's definitely one of the integrations that we have on the observability side of things. So anything that basically can generate alerts can integrate with PagerDuty in theory and in practical terms, but we do have some built-in integrations in PagerDuty, and Elastic is definitely one of them. So this is just a quick video. I'll show you how to do this, but basically this kind of shows you how to create an alert. This is using like the Elastic Observability stack, but you can also raise like security alerts from Elastic as well and integrate with PagerDuty easily. And this integration basically allows you to tie all the alerts coming from Elastic into actions on the PagerDuty side, and you'll be able to customize all of this information that is sent to PagerDuty. So enough slides. So I'll show you. We will actually show you a quick demo of. I will use basically as a reference an open source project that is actually provided by Elastic. It's available on GitHub. I'll share the links later. So this is something that you can try out yourself, and I will show you how to set this up and set up the alerts, send information into PagerDuty, and hopefully try to show you like some of the capabilities, not only on incident management, but also AI ops and automation. All right, so let's start. So this is the demo that we will be using today. So this is just like a demo application, as I said. So you can buy a bunch of stuff here. And actually, I think my proxy just went down. Okay, this is a demo. That's fine. Let's start it again. And there you go, working as expected. So Basically, this is just like a e-commerce website. I can add items to my cart, and at this point, actually, I can't, and you will see why. Because I probably have some alerts already taking place. There you go. Basically, I have set up an alert on the on Elastic, and basically this is already taking place. So I'll show you what I have before I actually start. So this is the application. Okay, bunch of microservices built in different languages. We are using, in this case, as you can see, we have a bunch of different services. I hope you can see a bunch of different services in Node.js, in Go, in Java, in Python, many different languages, all communicating through with each other. And we can see already from, if we go to the inventory, we can see already that we have some failed transactions here. And there is actually one active incident on the front end, right? So if I navigate, I can, from an incident management perspective, I can go directly into Elastic here. But one thing that I wanted to show you is that while I was doing or showing you the slides, something was going wrong, right? So I received a notification on Slack. The only reason why you didn't see it is because I have disabled notifications popping up on this specific channel. And yeah, I was getting called on my phone as well, right? So here I've received a notification. I can see that there is something going on in this specific service. I can see that this is the web front end. This is an incident with a high urgency, and I'm actually the one on call. So I've been assigned to the incident. And from here, I can actually start with any of these actions that I can acknowledge the incident. I can run a workflow, or I can do other things that I will need to do as a responder, such as adding note or adding a task, or basically reassigning or escalating or reassigning an incident to someone else. But as the first on-call responder, I need to start with acknowledging the incident, right? And this is where the fun starts. So I've acknowledged the incident directly through Slack. No need to open PagerDuty portal whatsoever. And you can see that things are moving, right? You can see that we have actually created a new channel, or haven't done anything, right? But something happened. New channel dedicated to this incident was created in Slack. So you can see all the information here. I've updated the channel topic as well. And I've already run a few like diagnostics without doing anything, actually. So all of this was powered by automation, right? So my service is running in a Kubernetes cluster, and I just ran a command to get the pod status, and I can see that one of my services is actually not working as expected, right? So, and this is, I'll show you the magic behind this. I just wanted to show you what's possible. And this means that, and this is one of the powers of all of this in the automation side of things, is that imagine that you are like, so I'm the one building these services, right? But I do have an help desk team. I do have like a first level of support in my organization. And typically they don't have access to our Kubernetes clusters. They don't have permissions to, right? But if I provide this in an automated way for them, they can actually do like a deeper analysis on what's going wrong, and they can escalate, hopefully, in fewer situations than they do most times. So this means that my support will be a lot cheaper, and I will be, well, I'll have time to actually focus on the product and not spending all my time troubleshooting what's wrong. So yeah, so let me show you quickly what happens on the PagerDuty side, right? So you go into the PagerDuty service. I have all my services listed here, and this is a demo environment, so standards are not great. But yeah, so here you can see that the web front end is actually having an issue. And you will see here that there is the incident that I showed already in in Slack. And you will see some additional information here as well, right? So we don't need the same type of information in Slack that we need here. But you can see the notes that you saw in Slack, right? So posted everywhere you are. You can also see that like the Slack channel. So I can actually click there and navigate to the Slack channel directly. You can also see that conference bridge was automatically created as well. In this case, in Google Meet, but we can do it in other platforms that we might be using, like Zoom or Microsoft Teams. I just wanted to show you something a bit different. And here, and this is one of the capabilities of AI Ops, is that you can actually have things like intelligent grouping for events. And here, so instead of having like an incident being triggered by like an individual alert that you receive, you can see that this is something that you can see like events being grouped together. In this case, Elastic, I must say, is one of the tools that, when compared to others, doesn't generate a lot of noise. So from a PagerDuty perspective, if I had like multiple alerts, which I don't have because you guys from Elastic do a lot of that job, kind of making sure that you don't generate a lot of noise on the alerts, I would see like multiple alerts being aggregated and grouped together in this incident. In this case, I only have basically one incident at this point in time, right? And you can see like the summary of the event. You can see the alert details, so I can navigate directly to the alert inside of Elastic. Same thing from a source perspective. You can see the source or in the service name. So all of this information is here for me just to use, all right? And if I go into, once again, into the alert on Elastic, I will show you how I created this integration, basically. So in this case, I have a very simple rule, and all of this by just generating by using the UI. So I'm not an advanced user on Elastic, so I could use like Kibana query language, but I haven't done it. So I've used just what's provided in the UI, and I've used one of the default actions that Elastic provides as well. So created a connector. In this case, I created a connector specific to the service, but I could have created like a generic connector to PagerDuty, and then on the PagerDuty side have some rules that would basically point or route the event to a specific service based on the service name, for instance. In this case, for demo purposes, I created one just specifically for this event, and basically I'm triggering this on every status change, and there are 3 actions that I can do actually when I use this action. So I can trigger a new alert in PagerDuty. I can resolve an incident, or I can acknowledge the incident. In this case, I'm going to trigger an incident on the PagerDuty side. And so I have a deduplication key, because if I want to do any operation on that same event, I will need to use this deduplication key. I'm providing basically information that comes from the specific context of this alert, right? So the reason I'm defining the severity as critical all the time, but I could do different types of severities as well. Finding a timestamp, basically the service name, and also some custom details. And this is the information that you saw on the incident, like the service name, alert details, and the source. So all of these are parameters that exist in the context of this alert. And then I have a second action with a slightly different trigger, which is when the status changed and the status is recovered. So the alert is not triggering anymore, or is not active anymore. What I'll do is I'll trigger resolve action on the PagerDuty side. So if something goes up, and it means and for some reason is like a transient issue that we are having, this means that the incident will auto resolve, and I will not be notified again on that specific issue, right? And so one last thing that I wanted to show you here is basically on the automation side of things, and show you all that magic that happened, that took place when I acknowledged an incident. And this is something that is part of our like automation stack. It's called incident workflows. And this is basically where you can set up a bunch of automations that will be triggered on specific conditions. And in this case, let me just show you what we have here. So basically I have this incident workflow that is getting triggered when the status changes to acknowledged, right? So every time the status changes to acknowledged, and this is or an status of an incident changes to acknowledged, and it's related to the web front end, then I will do a set of actions that I have here on the left. And we have seen them taking place live, right? So we have this create Slack channel for incident. Once again, all of these can use the context of that specific incident, right? So we are getting the incident number to generate the channel name. The channel can be either private or public. In this case, typically we want it to be private. I'm just setting a channel topic for demo purpose. I could potentially even bring some context information as well. This is using like a connection that I have in my PagerDuty organization to a Slack workspace. And I'm creating a Google bridge here. I'm adding that conference bridge that was generated in Google. So as you can see, I'm using the steps of Google Meet create meeting, and I'm grabbing the meeting URL, and I'm adding that information into the incident. And then I'm doing something that Bruno will show you in a bit more detail. But basically, I'm running an automation action. And this is basically the query that you saw earlier, where we got like the status of all the pods specific to this service, and extracting that information not in a kind of log way where you see like a JSON payload or it's just some text, but basically we are kind of giving you like the red and green signs just to make it easier for you to read. So we already processed all the information and share it with you. And there are a few more actions that you can use. So we have actions specific to like some of the cloud providers. We have some additional logic that will allow you to have like if then else conditions, to have some more complex workflows. We have a lot more actions from like a PagerDuty incident management point of view, where you can add like other responders or some business stakeholders to the incident, or eventually send a status update when, let's say, an incident is finally resolved. So you can send a status update to other people in your organization. So there are a bunch of integrations, and there are always more coming. One thing, and this is I'll pass this to Bruno now, but basically one thing that I wanted to mention here is that we now have this like web API integration or action here in incident workflows, which means that anything that is available through an API, you can bring to your incident workflow, so you can automate a lot more things. You don't need us to provide an action for you. So you can basically do anything that is possible through REST API. I think this one is very powerful. So I will just, yeah, I can publish the changes here. Doesn't really matter. And Bruno.
Thank you, Tiago, for the demo. So focusing a bit on the automated actions that Tiago was showing here. This can really be really helpful. As you could see, Tiago acknowledged an incident and could immediately see information from the platform that he was looking at in real time, which can be really time saving because you don't need to connect to your platform. You don't require a jump server to connect to your host or a VPN connection. Yeah, everything is done in the background. So let's have a look on what's under the hood on that automated action. For that, PagerDuty has automation solutions to help customers to really step up their game on the incident management. And that's, we have 3 products for that. I mean, we have Rundeck OSS, process automation, and Runbook automation. Not sure if anyone in the room knows Rundeck and ever used Rundeck before in their tech stack. Yeah, Rundeck is a popular automation product that can allow you to run and schedule jobs in a very easy manner. So PagerDuty has that offering as a OSS product, as a community product where anyone can download and give it a try. And then we have the enterprise version of that, which is process automation, which is self-hosted. You need to host that in your platform, or use our Runbook automation, which is provided by us, has software as a service, which we are using this on this case. So we call it Runbook automation. What is this? In Runbook automation, we have different components. I will start by the projects. A project, it's like a namespace, let's say, that can allow you to have different settings in your project. Let me just search by the project that we are using here. All right. So a project contains jobs, nodes, commands, webhooks, and many other settings. Just to help you on the terminology on this, a job is an action that you want to execute. Could be a script, could be an AWS command, a Kubernetes command. So there is a lot of options there. Nodes are the hosts that we are managing, that we want to somehow manage with these jobs that we are providing. And then webhooks, it's just like a regular webhook. We can expose a job as a webhook to be used by other applications. So let's have a look on the jobs. You can really think about what can you do on a terminal, right? You can put many commands or scripts on a terminal. You can basically expose that as a job in your Runbook automation, and then have a really much faster way to execute it and to use it. For example, just giving here a glimpse on the Kubernetes jobs, because our demo it's based on Kubernetes, so quite helpful to have this. Yeah, you can have jobs to get metrics from the system like CPU and memory statistics, to restart pods. Maybe one of the actions that we take when we have an incident is to try to restart it to see if that comes back correctly. So a restart could be exposed as a job on this, or even get more diagnostic data, has logs from a specific application or pod. So just show you the Java thread dump job as an example of this. This is just the page where you can run the job manually. It allows you some input options. You can really specify, okay, for this job, I need the pod name, for example, or the namespace. And that way you can have a generic job that can be reused for many different use cases. And having a look on the definition, this allows us to have a look on the job, what is inside of it. So we can have an action to execute commands, on this case, to retrieve process ID, and then to get the Java thread dump exactly from there and save it to a file. And lastly, to update it to upload it to a S3 bucket, so it's available on a different way. So all of these is just a way from a click of a button on Runbook automation. Also, these are just a regular job. Just following 4 steps on this case. We can define a workflow strategy. This is a simple one, but in case you have a complex one with a lot of conditions, with different branches in your workflow, you could really specify here, all right, we will only run the last step, upload to the S3 bucket if you have an option enabled in your job. So you can really tell and really model complex workflows in your Runbook automation. All right, so how does this connect to the PagerDuty side of things, as Tiago was showing before? So in our PagerDuty, we have the automation tab, and we have the definition for the automation actions. And here we have 2 tabs, one for the actions and one for the runners. A runner, I didn't mention before, but just a way to connect your platform to our cloud offering, to Runbook automation. On this case, we are connecting one environment. You can have multiple connections to different environments. If you have a AWS environment, you can have a runner there to dispatch jobs to that environment only, and others in different areas. And here we have the actions that were already created. And as Tiago showed at the beginning, I really like that diagram with a lot of tools and a lot of connections between different tools. Yeah, sometimes it's painful to automate something. But here we can really easy. It's really easy to add a new action using PagerDuty in combination with Runbook automation, because we can just click add an action. We select our runner, and we will see the jobs that were already created and developed by someone in your Runbook automation available to be exposed in your incidents. So it's an easier way, let's say, to get things connected and automated. On this case, for example, yeah, we can add this job that someone did to collect the top memory consuming processes, which can be helpful when you have a memory issue. So getting that information just right when the incident is created, it can be really helpful. So creating this one automatically populates with some information like action name and description, but you could really now fine tune it. And we have to connect it to a service. So as Tiago showed before on the incident management, we have different services for different parts of your business. And you can tell, okay, this action is for this service. So you can really narrow down what are the actions possible in the different services that you have in your incident management. So you don't have the risk to have someone triggering a wrong action that will affect or create another problem on a different area. Just putting here the web front end. And also you can limit by teams. So in your PagerDuty, if you have teams with different layouts, you can really tell which team is allowed to run the action. So just creating this one. You can also fine tune it even more with arguments and node filters, but I will just create it for now. There you go. So if I go back to one of the incidents available in the web frontend, I should see that action available here at the run actions. So here you go, top memory and consuming processes. So this is essentially how Runbook automation and PagerDuty can be connected easily. As you saw on the demonstration from Tiago, when an incident is acknowledged, it immediately triggered that action that we see here on the notes. This is what we call event-driven automation. It's when it's an event, an incident automatically triggering an automation in your platform. But in case you would prefer to have more control on the workflow and have someone in the middle to really push the button to run the automation, that's also possible, because the automation actions are exposed here on this dropdown and can be run at any time that you like. So if we run it again, here the checkpot status and namespace, we can really run again the same job, and we could see in real time if that pod in specific was already back online or not. So again, you don't have to connect to your Kubernetes cluster, more connections, more steps to waste time, right? So you could really just see here the information in real time. But yeah, looks like the pod is still down, so someone has to fix it. Not me for sure. Yeah, if you think about this, it can really be a time saver, because yeah, just sharing some context here. My first job was, I was also a support engineer, and I was working in the second line of support. And yeah, I had many cases like this. The first line could only do a specific limit of actions, doing a restart and one or two actions more, and everything else was coming back to us. So it was, yeah, sometimes painful to always get that burden to, yeah, respond to those cases. And if we have such a framework where you could say, all right, first line, when you have this problem, you can run these actions that we are developing for you guys to run. So we would still be the owners and set the boundaries of that team, but would give them much more autonomy. So yeah, if I think about this, it could really help me in my early days, but yeah, hope it can help someone else still. All right. Well, I hope this demonstration could really explain to you how the automation actions can really be helpful to your incident management. If you think about this, incidents are happening, yeah, almost, I mean, you cannot really prevent an incident to happen. It happens and it's in your table. So if you really focus on resolving them faster in a more efficient manner, it's really where you can make a difference, because yeah, they will happen one way or another. So really think about how can we help you on resolving them faster. So that's it about automation part for this demo.
Hi, everybody. I'm Lionel Palacin, and I'm working for Elastic. I've been with Elastic for almost more than 5 years now. And today I wanted to use the opportunity to be here with you to talk about RAG application and the role of Elasticsearch in RAG applications. If you don't know what Elasticsearch or a RAG application is right now, don't worry, we're gonna explain, talk about it. If you know already what it is, then you're gonna learn more about all of this. So maybe let's start with a question. What is NASA? If you ask that, that's a pretty simple question. If you ask that to ChatGPT, you get an answer like this. Pretty accurate. NASA is like a space agency. They are famous because they put someone on the moon. So yeah, accurate answer from ChatGPT, right? If we want to understand how it works, maybe we can have a look to like a high-level architecture view. So pretty simple. From that point of view, we have a question. We pass that question to a large language model. In my case, it was GPT 3.5 or 4 by OpenAI. But now everybody has a model, right? Google has one, Meta has one, everybody has its own large language model. They pretty much have all the same histories. They've been trained on like public internet data so that they know what NASA is. And they're able to formulate a human-like answer, right? That's the experience that everybody has with ChatGPT or large language model. But if I was asking as a Elastic employee, what is NASA? I would expect a different answer. NASA at Elastic is actually a sales team. It's a North American and South American sales team. So the acronym is NASA. So in my case, knowing that NASA is a space agency is not very relevant in my context, right? As an employee, I'm more interested to know exactly what's NASA for my day-to-day job. So how can I get a large language model smarter or at least aware of the context in which I asked the question? First, let's take a look at how the large language model are pre-trained. So they're pre-trained using like hundreds of millions of dollars, maybe billions of dollars, like ingesting all the data known to humankind from internet. And they use that data, they crunch it, they pretend it on like huge infrastructure. So they create like this base of the large language model. And that's where like the intelligence, if we must say, comes from. Then there's two ways to like add our domain specific knowledge, like our proprietary data, business data, my own data. So the first one is fine tuning. So basically you use pretty much the same process more or less in the pre-training. You have to have like some specific skills around data science, specific infrastructure to like fine tune the model. It's an area that has been very studied right now. A lot of money are invested in that to like be faster in fine tuning the model, reduce the cost for fine tuning the model. But it's still quite like a complex, costly, and not super efficient way of approaching that. And the last one is very straightforward, is RAG. So it stands for Retrieval Augmented Generation. And the way it works is as you ask a question, you have this context window that the LLM can take as the input. So you can have the question, you can have instruction about how the large language model is supposed to behave. And you can also pass context information like additional content that the LLM can use to formulate the answer. So if we look at the same architecture, but with that RAG approach, we get this. So we still have the question, but here you see you have your data. So it could be like documents, image, audio, video, what have you. And then you pass that as part of the context window. So you have the question, the context, you pass this to the large language model. And now with that additional information, they're able to answer the question as you expect. So if I look at that from like an input standpoint, I have my context window, and it contains a few things. The system prompt, so basically how the LLM is supposed to behave. So in my case, like helpful AI assistant, please give me an answer if you don't have the answer, just say you don't know. The context, so like the relevant part of the information, the question from the user, and then finally you get as an answer the output from the large language model. So let's take a look to like a simple example. Here I have a small application that we use as a demo platform. So what it does is a simple web application, and you can ask questions. And when I ask question, I do exactly what I show in the diagram. First, we get information from Elasticsearch. In our case, we have documents about like internal organization, company policy, and so on. So we use that question to get information from Elasticsearch. We pass that to the large language model, and we get an answer that's relevant to me. In the given context, NASA stands for North-South American region. Cool. So if I go back here, but the question you must ask yourself, okay, that's cool, but can I just put all my data into the context window? Some of the context window size by like the most recent model are quite large. Gemini 1.5 from Google has like 1 million token as an input, so it's huge. You can really put a lot of stuff in there. But some study actually I have found that it's not very efficient to do that. So if you pass like all your data, let's say you have, I don't know, an entire knowledge base about like how things work in your company, and you pass all of that to the LLM, you start asking questions, they find out that it might not be really good actually providing like efficient answer. And the second part, which is actually very important too, it costs a lot of money. Most of the provider of large language model, they charge by token that you send and the token you return. So the more you send, the more you return, the more you might pay. So the TLDR is try to only identify and pass the relevant information to an LLM alongside the question. No need to pass the entire universe each time you ask a question. So you might ask yourself, well, how to find the relevant information in like my proprietary data, in my knowledge base, in my internal data, right? Well, we have a solution for that is a search engine. And Elasticsearch is pretty good at this. We've been doing this for years now, for like 12, 14 years, I don't exactly know. And we started with full text search. So full text search is a very easy way and efficient way to search data. You're probably very familiar with full text search, something that's been around for years. When you like search on Wikipedia what is solar eclipse, you would get results that match the keyword that you actually type in the query, right? So full text search is pretty much keyword matching. If we take a look at how it works behind the scene, we have two phases. We index the document into Elasticsearch. We index entire data set. For that, we do a few transformations. We take all the words in the document, we tokenize them. So we remove like the stop words, like Z, A, the word that doesn't carry information. We transform them a bit, like lowercase them, stem them, and then put them in two different data structure. One is the inverted index, so it's very efficient to look up for terms. And the other one, the forward index, to know like how many times the terms is repeated in a specific document and so on. And at the query time, we do the same process. We take the query, so what is a solar eclipse? We tokenize it, keep only the meaningful token, and then we use them to search across our dataset. It's quite a straightforward approach to things. If we look at the query from Elasticsearch standpoint, we see we do a query match title. So that's the language to query Elasticsearch. And we get some documents as a response. So full text search is fast and cheap, scale very well. It's very easy to understand. I understand why my documents are matched compared to my query because I can literally see the words. But it has some disadvantage, like some weakness. It doesn't really work well with synonyms and homonyms. It doesn't do anything else other than text. You can't really search against image, videos, or audio using full text search. And most importantly, I think for our case, it doesn't understand the meaning of a question or meaning of a query or meaning of a document, the user intent. And that's where I want to introduce semantic search. Semantic search is a different approach to things. If you search for like today Pachelenata, you will, if you search for Pachelenata, you might type Pachelenata in the search engine, and you will get the document you're looking for because you are typing the exact terms that are in the document. But if you actually dealing with like a ChatGPT kind of experience where you like converse with your data, you ask a question, you might actually ask something like this, like what is the best cake from Portugal? Or what is a tart from Belém that I eat the other days? You know, you don't really know, you're really asking for to search for something. And in that case, none of the terms actually match the description maybe of the result. So that's where semantic search will shine, and that's why semantic search is very important for an application that deal with ChatGPT or open large language model. So to do semantic search, we have to talk about vector search. So it's a different way of searching than full text search. How vector search works? Well, from very high level standpoint, it works a bit like this. On your left side, you have like all your data sets, so like images, documents, audio, videos, what have you. You take those and you transform them into vectors, so a series of numbers. You do the same thing on the query side. You take what you're looking for, so it can be a question, it can be an image, a song. You transform it into a vector, and then you run an algorithm called nearest neighbor that allow you to find the documents or images that are the closest in the vector space than the query, and you get the results. So using this vector representation, you can really carry the meaning of the query, the documents. So let's dig a bit into that. What is a vector? Well, a vector or vector embedding is a way of representing your data into a vector space. So let's take a very simple example, a one-dimensional vector. It's a basic characteristic of my data. In that case, I'm trying to classify like some food. So one characteristic could be like richness to lightness, right? So Pachelenata would be more like on the rich side, and the croissant would be more like on the light side compared to each other. Then I can add multiple dimension. I can add like sweet to sour. The Pachelenata would be more like on the rich, a bit sweet. The croissant maybe like more the light, a bit less sweet. And then as you add like more data, the similar data starts to be grouped together. So we'll have like Pachelenata might be like closer to the cheesecake than the croissant can be. So all of that makes sense. And then you can do a vector search. So when you have all your data in your data set, you can search. So let's say I search for a pain au chocolat, and then I found that it's closer in probably in taste, texture, richness, sweetness to a croissant, and then maybe the cookie will come after, and then the Pachelenata, and then the cheesecake, and so on. So you really get, as you search, the closest neighbor. So that's very different approach than the full text search. So how do you generate those vector embeddings? You use a model. A model, it's very simple. It's an algorithm trained on large data set to encapsulate information into dense representation in a multi-dimensional space. In a few words, it takes as an input something. So in my case, I have a text embedding model, so it will take text as an input. And as an output, I get a series of numbers that represent that text into the vector space. If I have an image embedding model, I can take an image as an input and get a series of numbers that looks exactly the same. So then you need to store those vectors somewhere. So you need to store them in a vector database. Elasticsearch is a great vector database. It's implemented directly in Lucene. So if you don't know what Lucene is, it's a search library that's basically the core of Elasticsearch. implements fast similarity search in vector space. And because it's already in Elasticsearch, you can also use full text search, filtering, geo search, boosting, or everything that comes already in with Elasticsearch. Is using the HNSW algorithm for hierarchical navigable small words, I think, algorithm. I think that's probably the best nearest neighbor search algorithm right now. We're probably looking at adding others because that's a space that is evolving very fast. And it looks like this. So if you have a document in Elasticsearch with vector embeddings, you have your title, the text field, and you have like the vector representation of the text field. Yeah, look like numbers. So how do you search vectors in Elasticsearch? Well, first you need to ingest the data. So let's say you have all your data sets and you already have the embeddings. So that's fine. You can just directly index the document with the embeddings in Elasticsearch. If you don't have the embeddings, you can ingest the documents and generate the embeddings in Elasticsearch directly. So you will import embedding model in Elasticsearch and configure it to generate the vector embeddings at index time. So that part is free. You can index vector embeddings directly in Elasticsearch if you manage to generate them outside of Elasticsearch. That part is part of the commercial offering where you need to import a model inside Elasticsearch. And now when you have all your data set into Elasticsearch, you can search for it. So you do, let's say you're looking for summer clothes. What you do is like outside of Elasticsearch, you can generate the embedding using the same model that you use to index the documents. And then you pass in your Elasticsearch query, you pass the vector embedding in the KNN query. The query looks slightly different than the full text search query simply because it's not the same thing. Again, we have a commercial approach to that where you don't need, if you want to generate the embeddings for the query outside of Elasticsearch, you can import the model directly in Elasticsearch. And in the query itself, you just pass the query as plain text and provide the ID of the model you want to use for that. An alternative approach for semantic search. So here we talked about dense vector search. An alternative approach to implement semantic search is using learned sparse retrieval. So for that, we have a built-in model in Elasticsearch called ELSA that use a slightly different approach than dense vector. You use sparse vector, but it works very pretty much the same way. You take text as an input. We have a model called ELSA, and as an output, you get a text expansion of that text. I'll show you in the demo how it works. Finally, you can combine all of that. So you can combine full text search with semantic search, either dense vector or sparse vector, using linear combination plus RF. So basically, you can combine the search with full text search and semantic search easily with Elasticsearch. So now that we understand how Elasticsearch can allow you for full text search, semantic search, well, RAG can look like this. You ask a question, but when you ask a question, you're first gonna look in your data for the relevant information related to the question, then you pass that into the context window, and then the rest is the same. You pass that to the large language model that provides the right answer. So let's see how we can build that with Elasticsearch. So I already created an Elasticsearch deployment. Here we're looking at Kibana, a web application that allows us to manage our Elasticsearch deployment. And what I'm gonna do is look at the data I have already ingested. So I have a few indices. I have ones that contain the Wikipedia article and a few others that I will talk about a bit after. So the Wikipedia index basically contains a bunch of Wikipedia articles. And here, if I look in the document list, I can see that I have like the text and I have like all those tokens. So I have enriched the data using the LSAR model to enable semantic search on them. You can actually see like some of them repeat some of the document. It's simply because when you implement semantic search using vector search or LSAR, you most of the time need to chunk the document. Especially a Wikipedia article is very large text, and there is no model that's able to just take a very large text and generate vector embedding for those ones. So you need to chunk the document. So there's different technique of chunking. You can chunk by paragraph. You can have like repeated text in different documents and so on. So that's also an area with a lot of research right now. So I have my data into Elasticsearch. So I have like the first part. Now we can look at how we can search for that data. Let's say I look for pastel de nata. That works if I do that? Yep. Using full text search. Well, that works, of course, because I just typed the exact keyword that I was looking for, right? But if I were to do the same thing, if I were to look for what is the best cake from Portugal using full text search, well, in that case, the answers are going to be way less good because I simply don't carry the meaning in the full text search query, right? So the results in that case are not that good. If I try the same query, like what is the best cake from Portugal using semantic search, so we're using like the text expansion query to use LSAR. In that case, I get really good result. So I really built the first part of my application in RAG, retrieval, augmented generation. I really have like the retrieval aspect of it. I think it's pretty good now. I'm really able to retrieve my document from a question. So now let's move on and try to build the rest of the application. So we just introduced this notion of playground in Kibana. It's actually not released yet. It's going to be in 8.14 in a few days, weeks. That allow you to like start conversing with your data and building the RAG application. So how it works? I select an index. So here I gonna clear the chat. I select an index, and here's my playground. So what I have is like a model that I can choose. So I already set up connection to OpenAI to use GPT 3.5 or GPT-4. I have instruction to the assistant how it's supposed to behave. I can see the query. So the query is the exact same one that I actually type in the console, right? The text expansion and BD tokens. So if I type the same query, I should have the same result. I can close that and I can type what's the best cake from let's see if it works. Great. So what we did is we typed the question, we retrieved the documents from Elasticsearch. So here we have retrieved 3 documents from Elasticsearch using semantic search. We pass those 3 documents as context to our large language model, and it provides an answer that's pretty accurate. He even tells us like where he found the information within the context. So he said, okay, I found the information in the first document that you passed me. Here we can actually change. We can say you're an assistant that answers in Portuguese. So let's see. I think I have to change the model. Regenerate. I think that's how it works. So basically, you can change like how the large language model will behave. Let's see if it works. Yeah, it works. So that's the cool part of it is we're still asking a question in English. We retrieve document in English. We pass that everything in English to the large language model, but you just ask the large language model to answer to us in Portuguese. So we can really start like playing with different language very easily. So that's cool. I mean, I built this in Kibana, but you know, it's not very great to distribute to anyone if they want to use it. So I need to build that somewhere else. But the good thing is you can actually see the code. So here is the example of that application basically in Python. You can also use LangChain if you want. That basically do a few things. So let's me copy the code over here. And we can look at the code together. I'm just gonna save. So what does the code do? Well, you take a question. So I'm gonna ask the same question again. Just gonna copy it over because I'm tired of. Yes, I can try to do that. The font size. How do you do that? Command plus. Yes. Awesome. As good like this? Or more? All right. Okay, so what does the code do? To take a question, then we look at, we take the question and we find the document related to that question in Elasticsearch. So if I go up here, I can see my function. So basically take the query, run again, the same query. We just pass that and we return the document back to the main. Then I use those documents. So that's my context alongside with the question. And I create a prompt with that. So the prompt is basically my instruction, my context, and my question. I pass all of that to OpenAI and I get an answer. So let's try it. So I need to save. I think I need to export a few things. So don't copy my API key. Yeah, well, yes. And it didn't work. Why it didn't work? Base cake based on the pro. That's not cool. Maybe sometimes the LLM is just a bit. Oh yeah. Ah, what is it? What is the right answer? It's not Russia. Well, we need to change the data set. We need to change Wikipedia. So that's great. But you can say, okay, this is cool because you know we're working on Wikipedia dataset. Like, yeah, the large language model pretty much knows this. If I ask the same question to ChatGPT, it will know this. The interesting part would be to work actually with my own data. So what we can do is go back to Kibana. And here in Kibana, I have more data. I have this small data set. So that's basically like a few internal documents about like how Elastic is organized, company policy, and so on. And what we did, we take those documents, we ingest them in Elasticsearch, and we also generated vector embeddings using the OpenAI embedding model. So not to be confused with the OpenAI large language model. That one is just to generate vector embeddings to do semantic search again. So we have a text, a metadata, and so on. Now what I can do, again, I want to know first if I'm able to query my data. So here, I'm going to do my KNN search. I say I'm going to use the OpenAI embeddings and the model that I want to use. I say, what's NASA? And we get the document we have. So now maybe I don't want to reuse the Python code that we saw. I want to use like more like a real application. So here I will share the link after, but we have this like Elasticsearch Labs GitHub repository available And we have a few notebooks to learn more about how to do search in an advanced way, how to build RAG application. But what I really like is we have sample app. So this chatbot RAG application that look like this. So it's pretty much the one I showed you at the beginning. And so you can download it and easily configure it to query your own data. So that's what we're gonna do very quickly. So I already cloned the project and started to work on it. So I can try to run it. So I have the front end here. I'm gonna make it bigger. Running the front end, and I'm gonna run the back end very quickly. Let's see if that thing works. So I'm running my application. So now I can try to run my famous query, what's the NASA sales team? And it already works. So now, actually, I think I didn't save. Yeah, here I should have used something else. I think it's not gonna work. Yeah, so if I don't provide like something good in the context because the query didn't work, first there is no search results, and it gives me something that's actually not relevant to me. But if I go ahead and copy my query, so I'm just gonna copy that query. Replace the query directly in the code. I'm gonna save this. And we can try again. Okay, now I retrieve the documents as expected. So we learn how to use Elasticsearch to build a RAG application. We understand why search is quite important when you build such application because we can't pass all the data into the context window of a large language model. Vector search is definitely key here because you must have semantic search enabled to do such application, but it's not all, it's not enough. You need probably filtering and faceting. You probably need auto-completion, aggregation, document level security, hybrid search, geo search. So like search is more than just vector search. So that's something also to keep in mind when we build such application. Thank you for your attention. If you want to check the resources that I use to build the application, you can just go to Elasticsearch Labs. And if you have any question, I'm happy to take them now.